So these first few questions are really easy. So look at number 2. The sine of 45 is equal to the cosine of what angle? So you could use your unit circle to figure this out, but it's probably easier to think of it in terms of a right triangle. And in a right triangle, we usually have A, B, C. So this would be little a, little b, and little c. So if this is 45, then the sine of 45 is A over C. The cosine of what is also equal to that, and it ends up being the cosine of B. So this would be 45, and it works. Now, if this was 15, so the sine of 15 is equal to what? Well, if A is 15, what is B? 90 minus 15, which would be 75. So the sine of 15 will always be equal to the cosine of 75. And in general, they're always off by the complement of 90 degrees. So if I did the sine of 9987, whatever that is, right, round and round and round the unit circle, if I want to know which angle the cosine is equal to, so we just do 90 minus 9987, and I'll get the same answer every time. So the cosine of A is always equal to the cosine of B, and to find B, you just do 90 minus A. Okay. So number 6, the secant of B is equal to the cosecant of A. Or, well, they probably actually want you to do 90 minus B. Okay. What about the tangents? Does that also work with tangents? So if A is 15 degrees and B is 75 degrees, is the tangent of 15 equal to the cotangent of 75? Yeah, because O over A just turns into A over O, so you just find the complement. It's really that easy. All right. Write the trigonometric function values in terms of its cofunction. So take a look at your reference sheet, and on the bottom right corner, we have the cofunction formulas. Now, you might want to make a little note. You can either do cofunction formulas, well, actually every formula, in degrees or radians. The one listed on your reference sheet is in radians, so you might just want to do 90 minus theta. Okay, so number 8, the sine of 60 degrees minus x is going to be equal to what? So we have the sine of 60 degrees minus x. What is that equal to in its cofunction version? Well, the cofunction for sine says the sine of theta is equal to the cosine of 90 minus theta. Now I flipped that around backwards, but it's the top row right column. Do you see where I got that cofunction formula? Well, theta is just 60 minus x. So I'm going to plug 60 minus x in there. So the cosine of 90 minus 60 minus theta, which turns into 90 minus 60 plus theta. So the cosine of 30 plus theta, or x, I guess. It's supposed to be x. Do you want to see another one of those? Yeah, they're kind of confusing. All right. So number 12. The secant of 30 minus theta. What is the secant equal to in the cofunction formula? So it'll be middle row, left column, cosecant of 90 minus theta. And eventually you're not even going to need the reference sheet because it's always 90 minus theta for every one of them. So my secant formula has 30 minus theta. So I'm going to plug that in for theta, which gives me the cosecant of 90 minus 30 minus negative theta is plus theta. And that simplifies down to the cosecant of 60 plus theta. Okay, let me throw another one up there. The cotangent of x minus 15. What is that in terms of its cofunction, which would be the tangent formula? I don't need to look at the reference sheet. What is the cofunction formula for cotangent? The cotangent is equal to the tangent of 90 minus theta. Every time you just put the cofunction 90 minus theta. So cotangent is x minus 15. So I plug that in for theta. And I get the tangent of 90 minus x plus 15. Is everybody okay with that? Which gives me the tangent of 105 minus x. Okay, why do we care? Well, what if your cotangent button is broken on your calculator? Right? Or what if your sine button is broken on your calculator? You can just convert it into cosine. And it turns out we have sine, cosine, and tangent buttons on our calculators. You don't need all three of them. You only need one of them. If you have one of them, you can adapt every single trig expression into that using identities and cofunction formulas. Okay. Now, why do we care? Well, in calculus, sometimes doing calculus on tangent is way easier than doing calculus on cotangent. Or maybe doing calculus on sine ends up being easier than doing calculus on cosines. So if we have a cosine formula, we just change it into a sine formula, and it makes our life a lot easier. Okay. The next set, simplify each of the trig expressions. This is basically just convert everything to sines and cosines and simplify. And they're all going to simplify down to something pretty simple, like 1 or the tangent or something like that. All right, if you turn the page, they just get a little bit more complicated, but the same basic idea. So look at number 31. What can we do for 31 in the numerator? Factor it into 1 minus cosine squared and 1 plus cosine squared. Okay, look at number 29. 1 minus the cotangent of negative x. So we haven't talked about these, but in the middle of your reference sheet it says even and odd formulas. The sine of a negative angle is always equal to the negative sine of the same angle. And going down, look at the cotangent. Well, hold on, let's do cosine. The cosine of any negative angle is equal to the cosine of that angle, which is weird. The cosine of 30 is equal to the cosine of negative 30 every time, even in odd formulas. Right in the middle of the page. So for number 29, cotangent of negative x is equal to the negative cotangent of x. So you bring out the negative. And essentially, in sine, cosecant, tangent, and cotangent, if the angle is negative, you bring the negative out front. But if you're dealing with a cosine or a secant, what do you do with the negative? Just throw it away. Right? the cosine of negative theta is the cosine of theta. And then the secant of negative theta is the secant of theta. So for number 29, you just pull out the negative. Okay, that's it. All right. What? Right. So the sine of negative 25 is equal to the negative sine of 25. And the same is true of the secant, the tangent, and the cotangent. If the angle is negative, you take the negative and put it in front. That's true for sine, sine, cosecant, tangent, and cotangent. But the cosine of negative 18 is equal to the cosine of 18, always. The secant of negative x is equal to the secant of x. So if I ever see the cosine of a negative angle, to make my life easier, I'm just going to turn it positive. If I ever see the sine of a negative angle, I'm going to make my life easier by moving the negative in front. Right. So you can take out the negative on the cotangent, and then it hits the sine that's already there. Right. And that's true of sine, cosecant, tangent, and cotangent. But with the cosines, you just delete the negatives. Okay? Get to work.